Hola, mi clase. Today we are doing 7.2 Equations with Rational Numbers, Part 2. So today is going to be decimals. We don't have any key terms. So if you want, you can write none. All right. So, oh God, I almost cut it off again. Why do I do that? Anyway, so we're doing decimals today. So our trying to think. So there's two ways you can do these. So one way is you can just leave the decimals. We are using calculators, so you can just use your calculator and leave the decimals if that is easier for you. So I'll do this first problem, just showing you, you just solve them like an equation, like we have been, and we will just leave the decimals as is. So I have 95 hundredths x equals 55 hundredths x plus 60. I want to get my x's together. So just like with whole numbers, or integers, I'm going to subtract because that's the inverse or the opposite. Okay. And then I should probably grab my calculator too, just to check myself. But if we subtract 95 hundredths minus 55 hundredths, we get 4 tenths, right? So 4 tenths x equals, and then we have 60. Just like an integer, we're going to do divide by 4 because this is multiplication and the inverse is division. So I'm going to take 60 and divide it by 4 tenths. And I used my calculator and I got x equals 150. And I'm done. Okay, so you can totally do it that way. Another way you can do it is if you really don't like your decimals, there is a way to get rid of them. And the way you do it is you look at the largest, or in a sense, smallest place value. So if I look here, this is 100th, and this is 100th, and then this is, no hundredths. And so since my largest, or technically smallest place value is hundredths, what I'm going to do is multiply everything by 100. Now, it will make your numbers kind of large, but it does mean the decimals disappear and you don't have to worry about it. So when I times this by 100, I technically just get to move my decimal over twice. If you want to check it, just put it in your calculator, and you'll see that 100 times 1 and 25 hundredths is just 125x. Again, I'm going to move my decimal over twice, so I get 75x. And even with the whole number, here's my decimal, I have to move it over twice, so I'm going to go 5,000. Okay, and if you want to check any of those, you can times all of those by 100 just to check. Now the decimals are gone. I know that they're very large numbers, but you still have a calculator, so that shouldn't be a big deal, but this way you don't have to worry about decimals. So I'll let you decide which way you want to do it. So I'm going to still subtract 75x here. So I'm going to take 125 and minus 75. We get 50x equals 5,000. I'm going to divide by 50 just like I would if I had 5 or any other small number. And we get exactly 100. And another thing I could have done is remove these zeros first too if I wanted to. All right, I'm going to do this one similar to this, just to show you that it's not always 100. Just like with our fractions, we had to find that least common denominator and use it. All right, we found our least common multiple. It's very similar in a sense that this is my least common multiple. This is hundredths, and 1. If I wrote these as fractions, they would have hundreds under them. So there's where I get this from. So it's the same idea. This is a tenth. This is a 1. This is a tenth, and this is a tenth. Since that smallest decimal is a tenth, I'm going to multiply all these by 10. So it's very, very similar to my fractions. This time, I'm only going to move my decimal over once because I'm only timesing by 10. So I would get 73t plus, again, decimals back here for a whole number, so I still move it over, so I get 220 equals, move my decimal, 21t, move my decimal, minus 222. Okay, still have a calculator, which is really nice, even though these numbers are large. I'm going to move my 21. It's the smaller coefficient of my variable. This way it keeps these positive as much as I can. So I'm going to go 73 minus 21 right there in my calculator. I get 52t plus 220 equals negative 222. Don't lose that negative. Okay. Add 220. The inverse is to subtract 220. Oop, not 22, 20. Let me fix that. There we go. So if I take 222 negative and subtract 220, okay, I get 52t equals negative 442. This is multiplication. The inverse is division. Okay, again, you guys, I'm using a calculator too. I'm not trying to figure these things out. I'm making sure I am pushing the right buttons. And I get negative 8.5. And that's because a negative divided by a positive is a negative, right? I can always do an estimate. This is almost like 400 and then 50. Kind of get rid of those zeros. It's 40 divided by 5, so of course it should be close to 8. Make sure you're kind of keeping that in mind too. All right, so we have our additional practice. We're going to do some story problems with our additional practice. So Javier walks from his house to the zoo at a constant rate. After walking 75/100ths of a mile, he meets his brother Raul and they continue walking at the same constant rate. When they arrive at the zoo, Javier has walked for half an hour and Raul has walked for 2/10 of an hour. What is the rate in miles per hour at which the brothers walked to the zoo? So our variable is their rate, right? This is what we're trying to find. That's going to be our variable. So the way we're going to do this is we're going to set up an equation that has Javier's walk. We're going to set it equal to Raul's walk because that's what's going to get us our equal rates because they both walked the same rate. So I need to see how much he walked, and if they walked the same rate, his walk should be the same, right? Their variables should be the same. So Javier walked at a constant rate. And after this far, his brother met him. This information actually is going to go with Raul. And people confuse this, and we'll talk about it here in a second. But the reason it goes with Raul's information is because to make their distance equal, Raul needs this added to his walk, right? We need their distance to be equal because that's the only way we're going to find their rate being the same. So Javier's time is a half an hour and Raul's time is 2/10 of an hour. So for Javier, we're just going to take 5/10, I don't know why I wrote that backward, and multiply by x. That's his whole walk. He walked from his house to the zoo. It took him a half an hour. Now for Raul, he only walked for 2/10 of an hour. But we're going to add this 75/100ths to his because we need his distance to be the same as his brother's. So it kind of looks like this. This is Javier. He walks and meets Raul, and then they walk to the zoo. So this whole thing is Javier's, where Raul is this section plus the section his brother already walked, right? So that's why we have to take this 75/100ths and add it back to Raul's to make their distance the same. Alrighty, I'm going to have you guys solve this. I'm going to let you decide which way you want to solve it. You either can multiply and get rid of the decimals or not, okay? But either way, I'm leaving this blank now that it's set up for you, and you guys need to solve this. All right, Logan has 2 aquariums. One aquarium contains 1 3/10 cubic feet of water, and the other contains 1 99/10 cubic feet of water. The water in the larger aquarium weighs 37 and 44 pounds more than the water in the small aquarium. Write an equation with a variable on both sides to represent the situation. Then find the weight of 1 cubic foot of water. So this is very similar to the question up here. Okay, one aquarium contains this much water, the other one contains this much water. Okay, the water in the larger aquarium weighs this much more than the small aquarium. So this is going to technically go with our small aquarium because it's similar to the Raoul situation. Okay, so we don't know how much 1 cubic foot of water weighs. That's going to be our variable. So we know that the larger aquarium, and then it's going to be equal to the small aquarium, okay? So the larger aquarium is obviously the one that holds more water. So we're going to go 1 9/10 x because it holds more water. And then we're going to take the small aquarium, which is 1 3/10 x, but we're going to add the 37 and 44 tenths or 44 hundredths pounds to it, so that it's the same amount of weight now, okay? So it's very similar to this situation, okay? We've got that large aquarium to match with the small aquarium to get to the equal weight, right? Equal weight, we have to add this 3744 to the small aquarium's weight. Okay. All right, I'm going to solve this without removing the decimals. So I'm going to subtract 1 3/10 from both sides. We get 6/10 x. Okay, if you want to check that on a calculator, you can. I would appreciate if you did, just to check me. It's going to be equal to 37 and 44 hundredths pounds. So I'm going to divide by 6/10. This is where that calculator really comes in handy. I'm going to go 3744 divide by 6/10. And we're going to get 62 and 4/10. And there we go. So 1 cubic feet weighs 62 and 4/10 pounds. All right, so the main things to remember is if you want, right, if you want multiply by 10, 100, or etc. to remove the decimals, solve like a 7.1 equation. All right, so here's your independent practice. Again, you can treat it like it is, just leave it as is, or you can multiply by either a 10, a 100, or so on. When I say so on, I mean 1,000, 10,000, any number I need to get rid of those decimals. All right, until next time, adios.